Alrighty, quasi-experimental designs are when random assignment is not possible. So we can use different types of research designs to get around that and still be able to say that something is causal. So sort of review of what the classical experimental design is that there's an experimental group and there's a control group. In a simple experimental design, there's just two, sometimes there's more. There's a number and variation of experimental stimuli. So there's the intervention, the independent variable that we're interested in. Sometimes it might be a program or not a program, or different types of programs against each other. And then there's a pre-test and a post-test measurement. Sometimes there's multiple of them throughout, but there's always at least one pre-test and one post-test. And there's specific procedure for selecting subjects and assigning them to groups that is random. That's a key component of experimental designs. And so variations on this can be done by manipulating each of these basic blocks. So it might look like this, and these are all randomized experiments, right? And so we have the basic one over at the top, I don't know, my orientation's a little off the top, where there's there's a measurement prior to X, the intervention. So like I said, we might want to compare two different treatments like A and B. And so the differences we get there are the different effects of A and B, but maybe we also want a control group where there's someone not getting any intervention. And so that's the basic randomized design, comparing two treatments and a control. And then we have the pre-test, post-test, and control group design. And so we see that our observations are multiple in this case. And then there's also the alternative design as well. And so all of these are just differences in the randomized control setting and in how many interventions we're instituting or how many observations we're doing. And so they all have different strengths and weaknesses. Like if you want to compare multiple interventions, then a basic randomized design comparing two treatments might be really good. But it might be better to do a basic randomized design comparing two treatments and a control, right? And so you really need to think about your question and what type of experiment would best suit it. But sometimes we can't do random assignment. And sometimes we do a randomized experiment and it just falls apart. So we'll have a backup of a quasi-experimental design nested into the experimental design. And so because we're not randomizing, there's no built-in controls. We're not ensuring that there's no selection bias between the group that gets the intervention and the group that doesn't. And so there's a lot of internal validity threats, and we'll have a whole lecture on validity and its relation to experiments. And so if we can't randomize, then we at least can get to the point of an experiment which ensures that the control and the experimental groups are similar, right? So if we can't randomize them, let's at least make those two groups similar, is the idea behind quasi-experimental designs. So quasi means to a certain degree. So it's sort of experimental, but it's not, right? And there's two categories. There's non-equivalent group designs and there's time series designs. And non-equivalent group designs are whenever experimental and control groups are not equivalent. we have to select subjects in a way that makes the two groups as comparable as possible. And then time series is usually there's a time component into our design. So a common example is longitudinal studies, which we talked about in the first lecture about time and causation. And then there might also be like we're observing multiple observations over time. So time is a big influence in that. So non-equivalent group designs are when we can't randomize, we can't assume equivalency. We take steps to make the groups as comparable as possible. Sometimes we'll match subjects in an experimental and control group using important variables that are related to the dependent variable under study. So in the example I've been using of whether or not certain drug interventions are effective, we might pre-test people on their drug use. So we might actually line people up, match them. The highest drug use people get into two groups. And so there's a variation that's equal amongst those two groups. And we might match people based off of other factors that we might think might influence, like economic status or family supports and whatnot. So we have similar groups by matching people. And so it's like obviously we can't match people exactly, but if we have a big enough sample and we have enough variables that we can match on, then that ensures that when we do actually implement the intervention on the experimental group, that we're reducing any influences that might not be the independent variable, that might not be the intervention. So another non-equivalent control group design is cohort design. So this is when subjects enter or leave an institution at the same time. And there's a really classic example. So a really classic example of this is a study by Clark and Cornish, who are in the UK, I believe. They're criminologists, and they were looking at a Kingswood training school, which was a school that was actually terminated. And so because the study was allowed to measure those, there's like an instance that happened at the same time. So some people got to continue with the program until it was terminated, and some people didn't get the program. And so within the school, there was sort of a group of people who got the intervention and then a group of people who didn't, just because an event had happened. So this is when a group of subjects who enter or leave an institution at the same time. This is an example of that. And so another example is a class of police officers who graduate from a training academy at the same time, or all persons who are sentenced to probation in May. So it's necessary to ensure that the two cohorts being examined against one another are actually comparable, that there's no selection biases into which ones get the intervention or not. And in the example that I talked about the school, and we talked about buy-in in the prior study, so because the school was closing, there wasn't a lot of buy-in to do the experiment, right? Because the professionals were sort of checked out in regards to implementing the program. So another quasi-experimental setup is time series design. So it's longitudinal studies, like we talked about in the first lecture. We have time integrated into our study. We're observing observations over time. And sometimes something that we can use is interrupted time series, when there's actually like a policy intervention or something that happens that would interrupt the general trend that would happen for a specific outcome. So I'm trying to think of a good example. Like, let's say, let's say that there's, oh, here's a good example. Let's say that the minimum age for drinking just gets like higher at some point, like increased. So that law, if we were to look at like the amount of people who had DUIs, we saw that trend over time, and then we saw that policy intervention implemented. And then if we look after that year and see that the trend is like really different than the prior trend, then we can say that raising the age for drinking actually had a positive effect on the amount of DUIs. And so that's an example of an interruption to a time series, is that when there's a specific policy that would influence the outcome. And so we sort of compare the trends, and you'll see that usually the trend is like this, and there's a line, and then the trend on the other side is like a different line. So you'll see the stark change in the trend. But this has some limitations. So the instrumentation can be a problem. So observations are usually made over a relatively long time period, which increases the likelihood of a change in instruments. So, so often measures that are produced by an organization, such as police department, criminal court, probation officers, or corrections department, may be changed based off of that policy, right? So maybe if we're doing that experiment, like I talked about with DUIs and raising the age for drinking, then there may be some type of other policy implementation that happens that redefines how we conceptualize DUIs or something like that. So you really need to understand how your observations are being collected and if there's any difference. So we went briefly through all of these quasi-experimental designs. The statistical analysis of them is a little bit more complex, so I'm not going to give you a summary of what exactly it is for each of these. But I will give you a sense of how we could use quasi-experimental designs in criminal justice. So we can do a post-evaluation after we've instituted an experimental design. We can see how sentencing guidelines might be influenced by programs. We can also understand neighborhood crime prevention programs. And we can also, the interrupted time series allows us to understand different issues because researchers can't normally control how reliably the experimental treatment is actually implemented. So that's an issue that we went into when we get into evaluation. If we're instituting a certain type of program, it might be implemented differently among counselors, right? So our treatment actually isn't consistent across our control and experimental groups. The experimental group may be getting a variation in the treatment. So interrupted time series designs can be good for that, but history is an issue because there might just be general trends of increasing, and construct validity is also an issue. Neighborhood crime prevention programs are a good way for us to do sort of this randomization, right? Because if we can't randomly assign people to specific things, we can randomly assign neighborhoods to specific interventions, and that's not as much of an ethical issue as doing it for certain individuals, right? And so quasi-experimental designs allow us to look at these sort of larger treatment units and do that. Okay,